Okay, let's start. Let's start. Write down today new topic, rational functions and partial fractions. Write down new topic, rational functions and partial fractions. Rational functions. And partial fractions. This is very simple lesson, an important lesson. We don't have any direct question, but question number 15 there can be partial fraction part. Usually it has partial fractions, and question number 12 again it has partial fractions part. Then for our A-level paper there can be 4 marks out of 100 for pure mathematics. Then this is very important and simple lesson. First you identify first, you consider rational function mean division of two polynomials, fx divided by gx. Here polynomial 1, here polynomial 2. Then this division we call rational. Rational function, okay. So we know that one. This is called rational function. Then here polynomial 1, let's say degree m, here degree, here let's say degree m, m and n. So anyway, any division we call rational. So one thing, m greater than or equal n, division possible, no? Then numerator degree greater than denominator degree, then this is we call improper rational functions. Improper rational function. And m less than n we call proper rational function. Proper rational functions. So that is about rational functions. So see few examples. Consider y equal x over x minus 1, y equal x plus 1 over x square plus 1 times x minus 1, y equal x cube plus 1, x square plus 1 to the power 2, x plus 2. So here denominator degree greater than numerator, no? Here denominator degree greater than numerator. In each case, denominator degree greater than numerator. Then y equal x square plus 1 over x times x minus 1. Now degrees are same. Y equal x cube plus 1 over x plus 1, x minus 1, x minus 2. Now numerator degree greater than denominator and they are same. So here these three we call proper and these two we call improper. Improper rational functions. Okay, this is the thing. Okay, just you write this note first. Here put x squared, okay, x squared. So these things we know, just write. Okay, write subtopic partial fractions and write this example. Here 1 over x minus 1 plus 2 over x minus 2. Simplification process, get in common denominator, cross multiply, simplify this. Then here 3x minus 4 over x square minus 3x plus 2. So then this one we call simplification process. This process we call simplification. Then reverse process we call finding partial fractions. Reverse process we call finding partial fractions. We have few different techniques to do that. Later we will see what is that. Just write. Okay. Now you just write down the reverse process of the above simplification. The reverse process of the above simplification. The reverse process of the above simplification is known as finding partial fractions. Is known as finding partial fractions. Is known as finding partial fractions. Finding partial fractions. When finding partial fractions, when finding partial fractions, follow the following steps. Follow the following steps. Okay, number one, identify whether the rational function is proper or improper. Identify the rational function whether it is proper or improper. Okay, within bracket write down. If the function is improper, if the function is improper, use Lone division or division algorithm. Use Lone division or division algorithm to find quotient and the remainder. To find quotient and the remainder. To find quotient and the remainder. Quotient and the remainder. Step 2, second point. Completely factorize the denominator. Completely factorize the denominator. And identify different factor types. Completely factorize the denominator and identify the different factor types. Identify the different factor types. Okay, now you see Ax plus b format we call linear factors. Ax plus b to the power n type, here n positive integer greater than 1. Then we call repeating linear factor. Then ax squared plus bx plus c. This is we call quadratic factor. Then ax squared plus bx plus c to the power n type, where n positive integer, n greater than 1. We call repeating quadratic factor. Repeating quadratic. So we know these things. Okay, these are different factor types. So just write it now. These are different factor types. Okay. Now just see. So according to these factors, we can split that. We can split the other way. Take this example, 2x minus 1 over x minus 1, x minus 2. Let's see, we have to get partial fractions here. So anyway, we have denominator factors. It has completely factorized, no? And this is power 1 here, degree 1 here, degree 2. Then improper, no? Improper, sorry, proper 1. Then here the way, first you split it, x minus 1 and x minus 2 like this. Separate with plus sign. Then you put constant upstairs, a and b. So we know in division algorithm, when we have here power 1 relation, numerator will be power 0, 1, no, constant. Here linear 1, you put constant here. Now 2x minus 1, you multiply with this factor both left hand and right hand side. Then this will disappear. Then a times, then you can cancel x minus 1 and x minus 2. Then b times cancel x minus 2, you write x minus 1. So now this is identity. This is an identity, no? So we know these things. By this relation we can find AB, no? We can find AB. We know the procedure. Now just substitute x equal to okay, here 2 times 2 minus 1, here a, this becomes 0, 2 minus 1, then b value equal 3, no? Let x equal 3, let x equal 1 because of this factor. 2 times 1 minus 1, here a times 1 minus 2. Then here 1 minus 1, a value minus 1. Likewise, you find a and b. So after you get in a, b, then you can write partial fractions. 2x minus 1 over x minus 1, x minus 2. A value minus 1 over x minus 1 plus b value 3 over x minus 2. Now here are the partial fractions. Then the technique is very simple. So first you have to write this one. Thereafter, the procedure we have discussed previously, finding unknown part. Then by that, you can find unknown. Then finally you can write partial fractions. Do that example. Okay, now we have to practice how to write this relation, that's it. So we have 4 different factor types: linear factor, repeating linear factor, quadratic factor, repeating quadratic factor. So as according that, we have to write that initial step, no? Okay, see this. Now you consider 2x minus 1, x minus 1, x minus x plus 2. Here x square plus 1, x square plus 1 over x minus 1 cube x plus 1 2x minus 1 x squared plus 1 x minus 1 3x squared plus 2x minus 1. You get x squared plus 1 to the power 2 x minus 1 kind of thing. Let's say 4 here. So now you identify here case 1 linear factor in denominator, and case 2 here especially we have repeat in linear 1 and linear 1. Here linear factor. Here third case, so we have quadratic factor here and one linear factor. And fourth case, we have repeat in quadratic factor and linear factor. Okay. Now let's see how to split this. Identify. So we have two factors now. You separate it, x minus 1 and x plus 2, like this. Then linear factor, you put constant here, AB. That's how we split. So if you have further linear factor, you take that one again. So now for this case, this is somewhat special. Repeat in linear. So 3 times repeated one. Here power 3 means 3 times repeated. Then you have to repeat this way, x minus 1. Then next again repeat x minus 1 squared. Again you have to go x minus 1 cube. Likewise you repeat thrice. Here x minus 1 cube, repeat thrice. And here another linear factor, you write this way. Then here linear one, put upstairs constant. This is quadratic, but don't write linear one here, okay? This is repeat in linear. Here we have repeated it. You put constant, and here constant. So when you combine these three together, we get quadratic one, okay? So you don't write here bx plus c, you identify that is linear, repeat in linear. Then for linear word, you put constant. Okay, now here quadratic one, x square plus 1, x minus 1. Then quadratic one, you have to write here linear one. Write ax plus b format, and here linear, you put constant c. Then for linear, you put constant, for quadratic, you put linear one, no? Then here, so we have repeat in linear, repeat in quadratic, write here x square plus 1, again you repeat x square plus 1 to the power 2, likewise repeat, and x minus 1. Here 2 times repeated, here one first time, second time, here the other linear factor. So anyway this is quadratic now, you write upstairs linear. So here this is quadratic, then again you write cx plus d. And here constant, you write here e. That's how we write first step. Here this is linear, denominator has linear factor, denominator has repeat in linear factor, denominator has quadratic factor, and denominator has repeating quadratic factor. Okay, you note these different levels, not that. Ada Okay, you write here denominator has linear factors. Denominator has linear factors. Denominator has linear factors. Here denominator has repeating linear factors. Denominator has repeating linear factors. Right, by the side, right? Huh? Denominator has linear factors. Here denominator has repeating linear factors. Here denominator has quadratic factors. And here, right, denominator has repeating quadratic factors. Here denominator has linear factors. Here repeating denominator has repeating linear factors. Here denominator has quadratic factors. And here denominator has repeating quadratic factors. Those are the formats. Okay. Now you do example with me. Do another example with me. X minus 1 squared x plus 1. Okay, here we have repeating linear and linear one. Repeating linear factor and linear factor. Okay. Now a over x minus 1, b over x minus 1 squared, you repeat, c over x plus 1. Here it is. Okay. Then we have to simplify this. Then multiply by this denominator factors, 2x plus 1. So we have 1x minus 1. You cancel 1, write the remaining. A into x minus 1, x plus 1. Here x minus 1 square, you forget this part, remaining factor you write here. C into we have x plus 1, then you have to get x minus 1 square. X minus 1 square. Okay, then by this you find unknowns. So this is polynomial identity. We know how to find the values now. Then substitute x equal 1. Then here 2 times 1 plus 1. Here this part 0. B times 1 plus 1. Then b value 3 over 2. Substitute x equal minus 1. Minus 1. Here 2 times minus 1 plus 1. Here 0, 0. Minus 1, minus 1. Then c value minus 2 plus 1 minus 1 or minus 2. 1 over 2. Then x square coefficient, here you will get x square minus 1, then x square coefficient a. Here this side 0. Here x minus 1 square, no? X minus 1 square. Then x minus 1 square minus 1/4 answer. 1/4 answer, no? Then x square coefficient, here this x square minus 2x plus 1, we have x square coefficient c here. Here a plus c. Then a value equal 1/4. Then we know constant. These are the constants. Then finally partial fractions. 2x plus 1, x minus 1 squared x plus 1, a mean 1/4, b mean 3 over 2, c mean minus 1/4. Here it is. Okay, do that example. okay මෙතන මේ පොඩි දෙයක් තියෙනවා සමහර වෙලාවට ඔයාලට ඉස්කෝල වලදී වෙන්නේ මේක මේ වැලියු සබ්ස්ටිටියුට් කරන එකට වැඩි ටිකක් කැමති නැති වෙයි හරිද කැමති නැති වෙයි ඕක 2016 17 වගේ තිබුණ ප්‍රශ්නයක් ඒක උනන්නේ මේක නිව් සිලබස් එක ඒ කාලේ තිබුණා මේක සිලබස් එකේ වැලියු සබ්ස්ටිටියුට් කරන එකට ඩිස්කෂන් එකක් තිබුණා ඒක බෑ කියලා මේ රැෂනල් ෆන්ක්ෂන් එක x = 1 ට ඩිෆයින් වෙන්නේ නැහැ x = -1 ට ඩිෆයින් වෙන්නේ නැහැ. ඒ හින්දා මේකට දාන්න බැයි නම් මේකට දාන්නත් බෑ කියලා ඩිස්කෂන් එකක් තිබුණා. ඒ වුණාට ඒ ඩිස්කෂන් එක පස්සේ වැලිඩ් නැති වුණා. ඒ කියන්නේ අයින් වෙලා ගියා. මේ පොලිනෝමියල් ෆන්ක්ෂන් එක ඒ කියන්නේ මේකේ ඩොමේන් එකක් සෙට් කරනකොට මේ වැඩේ වෙන්නේ. එනකට වැලියු අන්නෝන් වැලියු එක හොයන එකට ඒකේ අවුලක් නැහැ. එහෙනම් මේ වැලියුස් සබ්ස්ටිටියුට් කරන එකේ ඉෂුව එකක් නැහැ. සමහරට කිව්වොත් මම මේ කියන්නේ. ඒක දැන් සිලබස් එකේ කියන්නේ ආන්සර් ෂීට් වලට එනකොට ඒකේ වැලිඩ් ටිකක් නැහැ දැන්. එඳ මේ ඕනේ මෙතඩ් එකකින් ෆයිනල් ආන්සර් එකට ගිය හැකියි. නැත්නම් normally coefficient equal කරලා විතරක් යන්න කියලා මේ කියන තැන් කීපයක් තිබිලා තියෙනවා. හරිද? ඒකයි මම මේ කලින් කිව්වේ. ඒ වුණාට ඒකේ ප්‍රශ්නයක් නැහැ. ඒ ඩිස්කෂන් එක මේ පස්සේ ඒ කියන්නේ අයින් වෙලාම ගියා. ඒක හැම එකක් නැහැ කියන තැන මේ අන්තිමට කිව්වා. හරිද? හරි. Okay. You do another example with me. 3x plus 1 x squared plus 1 or x minus 1. Here quadratic 1, here linear 1. You write here linear ax plus b, you put here constant. Okay? Here quadratic factor, linear factor. Then this is proper rational function. Then 3x plus 1 you multiply, then ax plus b times, here we have x square plus 1, no? Then you forget this part, write remaining x minus 1. C times, here we have x minus 1, no? Then multiply by x squared plus 1. Now just substitute it, x = 1, then 3 times 1 plus 1, here this becomes 0. Then you write c = 4/2. Then all the other cases we have to equate coefficient. Therefore, expand this. Here ax squared plus c. A plus c x squared. B minus a x c minus b. Then you can equate coefficients. X square coefficient here 0. There a plus c. Then c we know a = -2. Then x coefficient here 3. Here b minus a. Then a = -2, b = then 1. Then likewise you can take hybrid technique. Value substituting and coefficient equaling technique you can gather together. So anyway you find unknowns. Therefore partial fractions now 3x plus 1 over x squared plus 1 times x minus 1 now identical with minus 2x plus 1 over x squared plus 1 is equal to over x minus 1. Here it is. Okay. Continue. Do alone. Do alone. Take your time. First you have to check whether the rational function is proper or improper. So all the given previous examples also proper. Then division not possible further. Then the denominator factors completely given. Therefore don't worry about that. Denominator factors are given. Therefore separate factors. Here quadratic write linear. Here linear one write constant. And continue. Complete it. Okay. Now do with me 3x squared plus 1 over x minus 1 x times x plus 1. Here we have three linear factors. You write here x, a over x minus 1, b over x, c over x plus 1. Then multiply 3x squared plus 1. Here we have x minus 1. You multiply with the other two. Here we have x. You multiply with the other two. X minus 1, x plus 1. Here we have x plus 1 multiply with the other two. X minus 1 times x. Now let x equal 0. Here 1, 0. B times minus 1 plus 1. B equal minus 1. Let x equal 1. Then here 3 times 1 square plus 1. 0, they are 0. 1 plus 1. Then a value equal here 4 over 2. Let x equal minus 1. 3 times minus 1 square plus 1. Here 0, 0. C times minus 1, minus 1, minus 1. Then C value equal 3, 4, 2. Here minus 2 plus 2, 4. So those are the values. Therefore, partial fractions 3x square plus 1 over x minus 1 times x plus 1. A value 2, B value minus 1, C value 2. Complete. Okay. Now see another example. See another example. X plus 5 over x square minus x. X square minus x. So complete factors not given, then you have to factorize this. X plus 5, take x outside, x minus 1. Now we can see factors, no? Now you follow same procedure, a over x, b over x minus 1. Likewise you split. So first step you have to factorize denominator and check whether it is proper or improper. Here x plus 5 degree 1, here degree 2, then improper, no? Sorry, proper. Then no division, further division, no? Then x plus 5 identical a into x minus 1, b into x. Now let x equal 0, then 5 minus a equal minus 5. Let x equal 1, here 1 plus 5, here b into 1, then b value equals 6. Then we have partial fractions, x plus 5 over x square minus x identical minus 5 over x plus 6 over x minus 1. Those are the partial fractions. Complete. Okay. Then you come to these questions and do soon. Take your time. Do alone. Do alone. Take your time. I wrote answers directly, but you follow that procedure. Later I'll say how to get that one. Okay. You continue. You take your time and check answers. Okay. Now you see shortcut method, but don't get that one directly. When you are doing partial fractions question, don't do that. This, but anyway, check. So you consider 3x plus 5 over x minus 1 times x plus 2. Let's see how to get partial fractions directly, but don't get this method directly. Okay. Now first of all, we have to check whether it is proper or improper. This is proper one, no? Then no issue. Then denominator factors given, then again no issue. You separate like this. Okay. Now let's say you need to find a value. Then you check denominator term, x minus 1, no? Then that factor 0 value is 1, no? That factor 0 value is 1. You go to left side and close that factor and substitute 1 for each x value. Eight over 3. So that is a value. Okay. Then here x plus 2. So let's say you need to find b value. You go to denominator, here factor 0 value minus 2. Close that factor and substitute minus 2 each case, each x value. Then minus 6 plus 5 minus 1 over minus 3, 1/3. Likewise, you can directly obtain. Okay. අර තව ලේසි වෙන්න කියලා ඔක්කොම වහගන්න එපා. Only that factor x minus 1 only, x minus 1. Okay. Do that direct technique, shortcut method. Shortcut method. That method only applicable with linear factors, not with the quadratic, not with the repeating linear one. You can do that for linear factors. Just right. Okay. Then you do this section. You do this section. So I'll give you 1 minute. Start it. Start it now. Take time. Do alone. General method you do. If you have any doubt, do with me. Here we have x squared plus x plus 1 factor and linear factor. Then here quadratic one, no? You put linear ax plus b. Here linear one you put constant c. Then 3x squared plus 5x minus 1 identical with ax plus b times x minus 1 plus c times x squared plus x plus 1. So first you substitute x equal 1. 3 into 1 squared plus 5 into 1 minus 1. Here this is 0. 1 square 1 plus 1. Then see 5, 8, 7, 7 over 3. Then you better to expand and rearrange the terms. A plus c x squared b minus a plus c x c minus b. Now equate coefficients. X square coefficient here 3 equal a plus c. Then 3 7 over 3. Then a value 2 over 3. Here 9 minus 7 2 over 3. Then constant here minus 1 and here c minus b. Then c value 7 over 3. Then b value 10 over 3. 10 over 3. Then you can write partial fractions. Final step, you write partial fraction. 3x squared plus 5x minus 1, x squared plus x plus 1, x minus 1, two-thirds x, b value 10 third, x squared plus x plus 1, c value 7 over 3, x minus 1. Complete it. Complete. Okay. Now you do this section. Okay, you do this section. Take little time. If you have doubt, do with me. Here quadratic one, linear one, ax plus b over x square plus 4, c over x plus 1, x square plus 3x minus 1, ax plus b times x plus 1, c times x squared plus 4. Then let x equal minus 1, here minus 1 squared, 3 into minus 1, 0, minus 1 square plus 4. Then find c value. Here 1, minus 3 or 5. Na? Here cancel 1, minus 3 or 5. Then you better to expand. Here ax squared plus cx squared, a plus cx squared, a plus b, x, b plus 4c. Then equate coefficient, x squared coefficient 1, a plus c, c minus 3 fifth, then a value 8 fifth. Substitute minus 3. Then go to x coefficient, here 3, here a plus b. Then find b value. 3 minus 8 over 5. 7 over 5. B value. Do alone. Then final partial fractions. A 8 over 5. B 7 over 5. Over x squared plus 4. C minus 3 over 5. X plus 1. Here it is. Check your answers. Okay. Now you come to these 4 questions. Do them soon. Do them soon. Take time. Take your time, finally check your answers. No hurry, take your time. Check these answers. Now check this one. So that is for proper rational functions. That is for proper rational functions. Now you see improper one, like x squared over x minus 1, x plus 1. Here this is improper, no? Here degree 2, improper. See this technique. Now it is divisible, no? Now it is divisible. We know according to division algorithm, power 2 quotient will be power 0, 1, no? 2 minus 2, 0, 1. Then you put quotient constant k. And the other part, we have two factors. You write usual technique x minus 1, x plus 1, here a, here b. This is quotient. That quotient you can obtain by getting Laurent division, no? But without Laurent division also we can get, using division algorithm we can find it, no? So now this is for improper rational functions. Now x squared you multiply, then k multiply with these two factors, x minus 1, x plus 1, a multiply with x plus 1 only, and b multiply with x minus 1 only. Now we can find values, no? Let x equal 1, here 1, here 2a, 1 plus 1. then a equal half. Then let x equal minus 1, then minus 1 squared, here 0, here 0, b into minus 1 minus 1, then b value 1 over minus 2. Now take x square coefficient, here x square coefficient 1, here x square coefficient k, no, only k, no? Then k value 1, a value half, b value minus half. Then final partial fractions, x square over x minus 1, x plus 1, k value 1, a value 1 over 2, b value minus 1 over 2, x plus 1. This is for improper rational functions. Okay, write subtopic partial fractions for improper rational functions. Partial fractions for improper rational functions. Partial fractions for improper rational functions. Okay, now with star mark write down. With star mark write down. For improper rational functions, at quotient with general partial fractions. At quotient with general partial fractions. Okay, do this example. Do that. Okay, now see another example. X cube plus 1 over x times x minus 1. Here improper, no? Denominator degree 2, numerator degree 3. Now it is fully divisible, no? It is divisible. Now here power 3, here power 2, no? Then quotient will be power degree 1 relation. You add degree 1 relation like ax plus b. By log division you can find this directly. Then further we have linear factors. Then you write usual way. Here this is quotient, here linear factor put constant, linear factor put constant. That's the thing. So when you are getting partial fraction, first step you have to identify whether it is proper or improper. Second step, then you have to factorize completely denominator. Then thereafter, you write this algorithm, no? Thereafter you go to finding unknowns. Okay, then x cube plus 1 ax plus b times x into x minus 1 c times, here we have x, no? X minus 1 d times x. Here the relation now. Then you can substitute values and as well as equate coefficients. Let's substitute x equals 0. Here 1, here 0, here minus c, here 0. Then c value minus 1. Then substitute x equal 1, x equal 1, then 1 cube plus 1, 0, 0, here d. Then d value equal 2. D value equal 2. Then equate coefficient, x cube coefficient here 1, here x cube coefficient a, no any other thing, then a value 1. Then x square coefficient, here this side 0, here x square coefficient minus a plus b. Then b value equal 1. Now we know a, b, c, d all, no? Therefore finally partial fraction a value 1, b value 1, c value minus 1, d value plus 2. Then for improper rational function also we use same technique. Then only one specialty is quotient, no? That is the specialty. Okay, do that example. Okay, now you do with me this section. X cube plus 2x square minus 1 over x square plus 1 times x. Here x cube 2x square minus 1 over x square plus 1 times x. This is also improper one, no? Here degree 3. Do with me. Do with me. Here degree 3, put constant k. Here quadratic 1. Then write upstairs linear. And here x, you put constant here c. Here quadratic 1, no? Write linear 1, write constant. Here quotient power 3, here power 2, then quotient degree 0, 1. X cube 2x square minus 1 identical k times x square plus 1 times x, ax plus b times x, cx square plus 1. Now k, x cube plus x, a, x square plus bx, cx square plus 1. Now you can arrange terms. Kx cube, a plus cx squared, k plus bx plus c. Now x cube coefficient here 1 equal k. Then constant here minus 1, there c. X square coefficient here 2, there a plus c. Then c value minus 1, no? Then a value 3. Then x coefficient here 0, here no x coefficient, here k plus b. Then k value 1, b value minus 1. Then final partial fraction 1 plus 3x minus 1 x square plus 1 c minus 1 of x. Here the partial fraction. Complete. Okay, let's start again. Okay, now I'll do special question. I'll do one special question. See this one? Okay, write this question. Write this one. Find partial fraction. Find partial fractions of 1 over x minus 1, x minus 2. Write down. Find partial fractions of 1 over x minus 1, x minus 2. Hence find hence deduce partial fractions of 1 over first one 1 over x minus 1 square x minus 2. Second one 1 over x minus 1 x minus 2 square. Third one 1 over x minus 1 squared x minus 2 squared. So this is special part. So here this part is the special one. Okay, you do first part. Just do first part. General technique, you do that. General technique, you do first part. I'll do the others. Take 1 minute. One over x minus 1, x minus 2 partial fractions. You find it? So I'll do that one directly. So here x minus 1, substitute 1 minus 1 1 over x minus 2. Here the partial fractions, okay. Now say first one. Now check this. Now this is very important thing. Hence deduce. Hence deduce mean that partial fraction we have to use, no? But when if you need to find partial fraction, we know direct technique for this. But here we need to consider hence deduce. That means this partial fraction must be considered. Think here 1 over x minus 1 square we have, no? 1 over x minus 1 square we have. Then let's see how to obtain that. Here take this partial fraction. Then first one multiply by 1 over x minus 1. See what will happen. 1 over x minus 1 times 1 over x minus 1 x minus 2. 1 over x minus 1 minus 1 over x minus 1 plus 1 over x minus 2. Now see, here we can raise this power, no? 1 over x minus 1 squared x minus 2. We can raise that power. Here 1, 2, 1, 1, 2. Then expand this bracket, minus 1 over x minus 1 squared plus 1 over x minus 1 x minus 2. Then further we know partial fractions again here. Here it is, no? You can put it there. Then for this you write minus 1 over x minus 1 plus 1 over x minus 2. Here it is. Okay. Complete that. Here this is important. Huh? So by initial one we deduce that partial fraction. We know direct technique, but direct technique is not the one that what I need. Okay, do that. Okay. Now same way you try these two. You think and do. Similar method you can apply. Okay. I'll give you 1-2 minutes. Okay. Start. If you have doubt, just see. Here initial partial fraction. So we have to raise power here. That's why I multiply 1 over x minus 1. Then we can raise this power. Then right side similarly you expand. Here we have to multiply this 1 over x minus 1, then expand. Then for this part we know partial fraction initially. Put it there, no? That's how we do. Continue. You think and do. 1 multiply with 1 over x minus 2, then 1 over x minus 2 times 1 over x minus 1 x minus 2. 1 over x minus 2 minus 1 over x minus 1 plus 1 over x minus 2. Then 1 over x minus 1, x minus 2 squared. Likewise, we can raise the power. Minus 1, 1 over x minus 1, x minus 2 plus 1 over x minus 2 squared. Then for this, again, rewrite partial fractions. Minus 1 over x minus 1 plus 1 over x minus 2. 1 over x minus 2 squared. 1 over x minus 1 minus 1 over x minus 2 plus 1 over x minus 2 squared. That hence deduced part, you have to think. That instant you have to think. Okay. Then third case, let's see. Third case, we have to square this. We have to square this now. Then first one, 1 over x minus 1, x minus 2, we know partial fractions, minus 1 over x minus 1 plus 1 over x minus 2. Now square both sides. Minus 1 over x minus 1 plus 1 over x minus 2. Then we can take here x minus 1 squared, x minus 2 squared. No? Then this is binomial. Binomial, expand it. 1 over x minus 1 squared plus 1 over x minus 2 squared minus 2 times 1 over x minus 1, x minus 2. Okay. Likewise, you expand it. Then 1 over x minus 1 squared, 1 over x minus 2 squared. Instead of this, you rewrite partial fractions, minus 1 over x minus 1 plus 1 over x minus 2. Now we have partial fractions. Now. Then 1 over x minus 1 squared, 1 over x minus 2 squared plus 2 over x minus 1 minus 2 over x minus 2. Here are the partial fractions now. Okay, likewise you have to think. Okay, complete it. Okay. Now you try this question, similar format, but you continue. Find partial fractions of 1 over x plus 1, x plus 2. Hence deduce the partial fraction of 1 over x plus 1 square, x plus 2, 1 over x plus 1, x plus 2 squared, and 1 over x plus 1 square, x plus 2 squared. Okay, do it. Same method. Huh? Do soon. Okay, check it. If you have doubt, do with me. 1 over x plus 1, x plus 2. You know how to get partial fraction for this now? Here the partial fraction. Okay, that is our partial fraction. So I did it once, okay. Now we need 1 over x plus 1 squared and 1 over x plus 2 squared and 1 over x plus 1 squared, x plus 2 squared. Then here this relation, first relation, you have to raise power by 1, no? Then 1 multiplied by 1 over x plus 1. Then 1 over x plus 1 times 1 over x plus 1, x plus 2. Then here this one, 1 over x plus 1 times 1 over x plus 1 minus 1 over x plus 2. Now when you couple these two, x plus 1 squared, x plus 2, here expand this bracket, multiply 1 over x plus 1 squared plus minus 1 over x plus 1, x plus 2. Then further we know partial fraction of this. Then you replace that here. 1 over x plus 1 squared minus, put bracket, for this one you put here 1 over x plus 1, 1 over x plus 2. Now here the partial fractions. 1 over x plus 1 square minus 1 over x plus 1 plus 1 over x plus 2. Then the initial one you have to reduce another 2, no? So by this one you think and do. You practice same questions again and again until you get that idea. Okay, then second one, you can use same technique. Then 1 into 1 over x plus 2. 1 over x plus 2 times 1 over x plus 1, x plus 2. Then 1 over x plus 2 times, instead of this part we know partial fractions, x plus 1, 1 over x plus 2. Then further expand 1 over x plus 2, x plus 1 minus 1 over x plus 2 squared. Then for this one again we know partial fractions. 1 over x plus 1 minus 1 over x plus 2 minus 1 over x plus 2 squared. Here the partial fraction. Okay, that is our partial fraction. So this is special one, okay, not directly general one. Then for this one, you square first relation, square that. Okay, let's see. 1 squared, 1 over x plus 1, x plus 2 square, 1 over x plus 1, 1 over x plus 2 squared, 1 over x plus 1 squared, x plus 2 squared. Then expand this, 1 over x plus 1 square binomial, 1 over x plus 2 squared minus 2 over minus 2 times 1 over x plus 1, x plus 2. Here binomial, a plus b squared, a minus b square, a square plus b square minus 2ab. 1 over x plus 1 squared, 1 over x plus 2 squared. Then for this one, write 1 over x plus 1 minus 1 over x plus 2. Now we got partial fractions. 1 over x plus 1 squared, 1 over x plus 2 squared, 2 over x plus 1, 2 over x plus 2. Complete. Now let's do general questions again. Okay, you try these questions. Okay, try these questions. So first you think whether it is proper or improper. Then you think whether we have factors in denominator. So if we don't have factors, we have to factorize completely, no? Okay, take time. Okay, first one, here 2x plus 5, here factorize denominator. Now here we have denominator linear factor and quadratic factor. Then write a over x, bx plus c over x squared plus 1. Then 2x plus 5 multiply a into x squared plus 1, bx plus c into x. Substitute x equals 0, here 5, here a. Then you better to equate x square coefficient, here 0, here a plus b. B equal minus 5. Then constant, okay, no? Then x coefficient, here 2, here x coefficient, we have only c. Then partial fraction, 5 over x minus 5x plus 2 over x square plus 1. Here it is. Take time. Up to now we have done everything under partial fraction. We have to practice only. Then second one, 3x minus 1 over x cube minus x. 3x minus 1, take x outside, x square minus 1. Further we have factors. 3x minus 1, x into x minus 1, x plus 1. You have to completely factorize denominator, okay? Don't stop here, you have to go further. Then here 3x minus 1, x minus 1, x plus 1, a of x, b of x minus 1, c of x plus 1. Then you find partial fractions. You have to proceed now. 3x minus 1, a into x minus 1, x plus 1, b into x plus 1, c into x minus 1. Here it is. Okay, then continue. Substitute values. X equals 0, minus 1, minus a. X equal 1, 3 minus 1, 2, 0, 0, here 2b, b equal 1. X equal minus 1, minus 3 minus 1, minus 4. Here minus 1, minus 2. Then c value equal minus 2. Now we know a, b, c values. Then you can write partial fractions. 1 over x, 1 over x minus 1, minus 2 over x plus 1. Okay, here are the partial fractions. Continue. Okay. Then last one. Three x squared minus 4x plus 1 over x cube minus 3x squared plus 2x. 3x square minus 4x plus 1, take x outside, x square minus 3x plus 2. Here factorize. Then 3x square minus 4x plus 1 over x minus 1, x minus 2. Here proper no? Then a of x, b of x minus 1, c of x minus 2. 3x square minus 4x plus 1, a into x minus 1, x minus 2, b into x minus 2, c into x minus 1. Now substitute 0. Then a value equal 1 over 2, substitute 1, b value equal 3, 4, 0. 3, 4, 0. Substitute 2, 4, 12, minus 8 plus 1. 12, 8, 4, 5. 5 over 2. Then finally partial fraction, 1 over 2 of x, 0 of x minus 1, 5 over 2 over x minus 2. That is the partial fraction. Okay. Now all the things we have done, take your tutorial, take this tutorial. Page number 15 and 16, page number 14 and 15, you have partial fractions, okay? Then page number 15, there are some special partial fraction question. No need to do up for now, but page number 14, 93 to 114, you can continue. You can do, okay? Just do few questions. From 1993 to 114, do one by one. Do one by one. Take time. Okay. Now, while you are doing that, check this special question. While you are doing, just see 120 question, 120. That is special one. So here x plus 5, x minus 2 to the power 1000. So we have to find partial fractions. Check this on all. We have to find partial fractions. Here 1000 times repeated, no? 1000 times repeated. Then we have to write a series a over x minus 2, b over x minus 2 square, c over x minus 2 cubed, so on we have to write, no? That is too difficult, no? Therefore, I'll do this say, let x minus 2 equal t. I'm going to use this substitution. Then x equal t plus 2. Then replace this. Then x plus 5 over x minus 2 to the power 1000. Now x equal t plus 2 plus 5. X plus 2 to the power 1000, 3 to the power 1000. 7, 3 to the power 1000. Now separate denominator. 7 t to the power 1000. Then cancel 1, t to the power 999, 7 over 1000. Now just replace again, t mean x minus 2, no? Then you can write this one because of that. Therefore, 1 over x minus 2 to the power 999 plus 7 over x minus 2 to the power 1000. Here the partial fractions. So if you go general way, that is too difficult. If you go general way, you have to find 1000 unknowns. But many of them are zeros. 998 will be 0. But you better to take this one as a single term. Then you better to use substitution x minus 2 equal t and proceed. Okay? Do that question while you are doing that. That is special one. 120th one. Okay, by that experience, let's do another one. 119. 1 over x times x to the power 100 plus 1. X to the power 100 plus 1. So I'll take here x to the power 100 plus 1 equal t. Here say t. Then x to the power 100 t minus 1. T minus 1. Okay, try now. Try. Okay. Now, first let's see the general one. Here general one, a over x. Here x to the power 100, no? B1, x to the power 99, b2 x to the power 98, b3 x to the power 97, it goes so on. b98 x b99 b100, no? Take 98, 99, 98, 97, here 1 b0 over x to the power 100 plus 1, then 1 identical with a x to the power 100 plus 1 x times b99 x to the power 99, b98 x to the power 98, it goes on, b1x b0. Now equate coefficients. X to the power, first constant, 1 equal, before that substitute x equals 0, then here 1 equal, full part 0, a equal 1, then x to the power 100 coefficient, here 0, a plus b99, then b99 equal 1 minus 1, x to the power 99 coefficient 0, here b98, then that is 0, then all the others are 0. Constant term before x coefficient, here 0, then similarly others are 0, okay? X coefficient, here 0, there b0, then b0 also 0, then all the other coefficients 0, then finally partial fraction 1 over x minus 1 over x to the power 100 plus 1, here the partial fraction. All the other coefficients are 0, all the other coefficients are 0, then thereafter you have to equate coefficients. Complete.